Welcome to part 2 of our ELSeWeb demonstration. In this segment, we will use the web probe tool to visualize provenance output from the ELSeWeb system. To kind of guide us to this viewing through web probe, we can resort back to our demo script that we were using for the first video. If you go to section 5, you'll see viewing provenance through web probe. The paragraph below is just a little blurb on why we would need provenance in such an automated environment like ELSeWeb. But I'll do this for reading later. If we go to step 1, what we'll do is copy the URI of a provenance trace that was actually output from WebProbe. I have this particular link open already on my browser, as you can see, and no surprise, it's more RDF. This RDF is actually following the vocabulary of the PML2 ontology, although we are rapidly moving to be dumping Prov, the latest W3C standard. So if you snag this URI up here of this provenance trace, you can navigate to the web probe tool, and the URL to the web probe tool is in the script. What you can do is simply locate the text input box and paste in the URI and click lookup. The system loaded it pretty quickly. What it did is actually downloaded that PML RDF to a server and then displayed back to the browser a visual representation of it. This first page is what we call the question and answer view. So if you look at this portion of text right here, this should look familiar to you. This was actually the Sparkle query that we used for the example in the previous video that orchestrated the pipeline that sent that EDAC data to LifeMapper. If you look below, we have a box. This particular box represents the output of that pipeline. So question being the query, answer being the LifeMapper experiment that was output from the service orchestration. And you can see the URL for this is lifemapper.org, blah, 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 experiments 59589. If we wanted to see how this particular result was generated, we simply click on the box. And WebProbe will provide a visualization of the provenance trace, as you can see. Now I'll zoom out for clarity here. And as you can see, you can drag the tree around. So this particular node furthest to the left is the final result that I clicked on in the question and answering view. And every node that sort of feeds into it is either a parameter or some kind of data set that fed into service that generated that final result. So let's zoom in and look at the first service that was captured in Provenance, which is actually the final service executed. And of course, it's a LifeMapper simulation service. You can see it and it had an output of the URL where the model can be found. Feeding into this particular service, we have a few parameters. So we see the algorithm choice, BioClim. We see username and password. We see the units, decimal degrees. And we actually see some data from the payload extractor. We didn't actually request in the Sparkle query for the payload extractor to be executed. The ELSeWeb system automatically deduced that we needed to inject this service into the pipeline in order to mediate the discrepancies between the LifeMapper data requirements and EDAC data properties. And you can see it's a little TIFF image of a scenario layer. In this case, we can follow the trace down to see what kind of data fed into that payload extractor. And we see that it was output from this service called Get Snow Coverage. So this is actually EDAC snow cover data that was fetched. So if you remember in the query, we were specifying for any data that was output from a MODIS sensor. This particular data was. So it was included in the service orchestration. This service too had a number of inputs, parameters to be more specific. We see that we were specifying a height, a width, a left longitude, a right longitude, a latitude, and a URL where it could fetch the data. Some of these parameters may look familiar to you GIS people. These are actually OGC, WCS standard parameters that go with any WCS service. So this was an example of how we can use WebProbe to trace to analyze provenance, and this is important because, as I said, there were some sources that were automatically injected into the pipeline from ELSeWeb. So in this case, it would be necessary to browse through the Provenance trace and ensure that the services didn't corrupt the result in any way, if there was a corrupted result. Another thing about WebProbe, just going into kind of its features, if you click any of these nodes, on this right side you'll be provided with the larger visualization, if there is a visualization within the node. Otherwise, if you click it, you'll just be provided with the text. Could be a URL or parameter setting. And that concludes this demonstration of WebProbe. Thank you very much.